Welcome to Lesson 1, Costs of Advertising. In this lesson, we're going to be exploring how much it costs to advertise in a print ad. So if you had a car, for example, that you were looking to sell, what would it cost you to place an ad in a newspaper? Our objectives are to define a piecewise function to model these advertising costs and to graph and interpret advertising costs. Below here, I've listed a chart that I thought was interesting, and it has to do with the younger generation losing interest in cars. And you'll notice down here in 1984, 80% of the age group, your age group, 16 to 24, was driving. But notice over time this trend. This line is decreasing and decreasing, and finally here in 2010, only 68% of your age group is actually driving a car. And it just made me wonder why. Is gas too expensive? Is insurance too expensive? Is there much better public transportation? I didn't know, but I just thought it was an interesting trend. Okay, let's look at our first example. This is how newspapers charge. In this situation, John plans to sell his car and he wants to place a 5-line ad. The newspaper charges $31 for the first 2 lines, but then an additional $6 per extra line to run the ad for 1 week. We want to know what John's ad cost will be to run it for 2 weeks. This would be a perfect example for a piecewise function. But let's go ahead and figure this out on our own. So, John plans to sell his car and place a 5-line ad. Very important. The newspaper charges $31 for the first 2 lines. So we know that John is for sure going to have to pay $31 because he has more than 2 lines. He has 5 lines. So if we take 5 minus 2, he has an extra 3 lines times $6 here per extra line. So he's going to have to pay an additional $18. Adding those together, we get $49. But again, remember, John wants to run the ad for 2 weeks rather than 1. So we need to double this or multiply it by 2. And we would get $98 for John's ad. That was relatively simple math to do, and we could do that in our head every single time. The problem is, what happens if instead of being John, you happen to be somebody who actually works at the newspaper? And you're getting multiple people calling in every day to place ads. You wouldn't want to spend a lot of time doing this calculation for each person individually. So what you want to do instead is write a program that can calculate it automatically. And for that program, we would need to use a piecewise function. And this will help us to be more efficient. So let's look at this example. Jason works for the Glen Oaks News and is writing a program to compute ad costs. He needs to enter an algebraic representation of the costs of an ad. His company charges $42 for up to 5 lines, and then each additional line beyond that 5 will cost $7. We want to express the cost of an ad with X lines, and notice I'm saying X lines because we don't know what customer is going to come in and how many lines they're going to want to purchase. So we say X for an unknown as a function of X algebraically. So let's go ahead and start off. Let's write our piecewise function. When we write our piecewise functions, if you remember, we have 1y, or f of x, means the same thing. And that is going to be equal to 1, or actually more than 1 because it's a piecewise function, but 2 or more functions depending upon the domain. The domain, remember, is our x-axis, which represents the number of lines. So it depends upon x right here. Well, let's look at our first example. The company charges $42 for up to 5 lines. So for our first example, we know that you're going to pay $42 when the number of lines that you want to purchase is less than or equal to 5. So it doesn't matter if you want to purchase 1 line or 2 lines or 5 lines, you'll pay a flat fee of $42. Let's go ahead and just graph that portion and see what that looks like. So what I would do is start right here at $42, and I would graph a horizontal line all the way here to up to 5 lines right there. So notice this isn't $42 per line. All I have to do is look down here to see how many lines I want to purchase. Say it's 3. Look up here, it's still $42. So this is a flat or horizontal slope here. Okay, let's move on to our second piecewise function, or the second portion of it. In this case, the company will charge $7 for each line above 5 lines. So let's go ahead and look at our domain first. Well, we need to say that when x is now greater than 5, so not equal to, just greater than, so it's beyond 5 lines, our cost is now $7. How do we write an equation to represent that? Well, just like the previous one, if you have beyond 5 lines, you still have to pay that $42 plus some additional fees. So the additional fees come to $7 times however many lines you have minus 5. And we say minus 5 because we've already accounted for the first 5 lines with the $42 right here. Okay, now how would we graph that equation? Well, if we're going to graph that equation, we could simplify this, put it in slope-intercept form, but that would be a little bit difficult. We know that our starting point is going to be right here. We just need an ending point. We can pick any one of these x values for an ending point as long as it's greater than 5. So I'll go ahead and pick, maybe I'll go ahead and pick 10. So if I plug 10 in here, 10 minus 5 is 5, and 5 times 7 is 35. If I add the 35 to the 42, I get 77. So if I look at my chart up here, here's 78. So 77 is just going to be shy of 78. Very close, just a little bit shy. So what I'm going to do is come to 10 because that's the number I picked, and I'm going to start there. That'll be my first point, and then I can make a connection here. If I wanted to now, because I have my line, I could extend this line out indefinitely. The advantage of having a graph is then it's very visually easy to determine what your prices are. For example, what if I wanted to run an ad that was 8 lines long? I would just go to the 8, look up here, and I could see that, these go by 6s. So this is 60 right here. 8 is probably $63, so approximately $63. What if I wanted to run a 7-line ad? I can again come up here and say it's just over $54. So the graph is a very visual way of seeing things, just like the graph on the very first slide that I showed you. All right, let's look at some understanding. In this situation, Roxanne set up the following piecewise function, which represented the cost of an auto classified from her hometown. X represents the number of lines in the ad, and we want to use words to express the price. So, looking at this piecewise function, how could you describe this in words? Well, if we look at it, it's very similar to the one we just finished. It looks like an ad will be $41.55 when X, which represents the number of lines, is less than or equal to 6. And then, looking at my second equation, I'm going to be charged an additional $5.55 when X, the number of lines, is greater than 6. So writing this in words, I would say the cost of an ad is $41.55 up to 6 lines. Beyond 6 lines, I will have to pay $5.50 per line beyond the 6. Okay, let's look at our last example. In this example, we want to write a piecewise function to describe the advertising cost structure shown here on the graph. Notice in this case, we actually have 3 distinct lines. We have our horizontal line that we're used to. Then we have a line here with a slope. And then we have a third line with a less steep slope. And we need to write a piecewise function to represent each. So let's get started. When we begin, we of course have our y, or our f of x. And then we are going to need to write, in this case, 3 different functions with 3 different domains. The first one should be pretty easy to write because it's just 3 right here. When y equals 3, we draw a line. So let's go ahead and write that. Y equals 3. And we need to write our domain for this. So it's going to be 3 when x is greater than or equal to, and if you'll notice here, this horizontal line goes all the way up to 3, and it includes 3. So when x is greater than or equal to, oops, that's a mistake, that should be less than or equal to 3, we have the function y equals 3. Not a problem. Let's go ahead and look at this one now. The easiest thing is probably to figure out our slope. We could pick 2 points and do rise over run. We could do y1 minus y2 over x1 minus x2, or we could just count. So I'm going to go ahead and count. Let's see what we have. So if we start here and we go to here, I'm going up 2 over 1. So we know that our slope is going to be 2 over 1x, but now we need to figure out what our intercept would be if this line continued on down. Since our slope is 2 over 1, I can count down 1, 2 over 1 to here, down 2 over 1 to here. And then if I went down 2, I would be at negative 3 over 1 to here. So in fact, our y-intercept is negative 3. That's one way to figure out what the y-intercept would be. The reason we don't see it is because our domain restricts us. We only are going to start here, but we still have to write the equation of this line as if it was a real line. So the equation of this line is 2x minus 3, or 2 over 1x plus a negative 3. Now let's write our domain. Our domain is between 3 and 5, but we won't include the 3 because we included it in the first place. So x will be greater than 3, and then we'll say less than or equal to 5. Okay, so we're going to include the 5 here, but not the 3 here because we're going to assume that's included in our first equation. Time for our final equation here. So again, let's look at our slope. We go up 1 over 1, up 1 over 1. So our slope is just 1 over 1x, or 1x, or just x. Now let's figure out what our y-intercept would be. Well, if I continued this trend the other direction, I would go down 1 over 1, 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 here to 2. So we have an equation of x plus 2. Let's figure out our domain. Our domain goes from 5, and then it goes forever. We don't see an ending. So we'll say that we start at 5, but we won't make it equal to 5. We'll say greater than 5, and then less than. Actually, we won't even put a less than or equal to because we don't have an ending. So let's rewrite this as x is greater than 5. Very similar to our initial piecewise function back here. And we'll go back to it, where x was greater than 5 because this line we're assuming goes off forever. Okay, and that concludes our instruction on cost of advertising. So hopefully at this point you can write some piecewise functions given a scenario. Also, you have a good understanding of when you look at a piecewise function, what does it mean as it relates to cost of advertising? And finally, if you are given a graph, that you can build 3 functions for these 3 different lines and write in a domain.